Let's go. Trapezoids today. This is it. Last figure I got to talk about. Trapezoid, isosceles trapezoid. Tomorrow's a little bit more review of all the coordinate stuff. So let me first talk about your basic trapezoid. Basic trapezoid. I hate to break it to you, there's nothing fancy at all about a trapezoid. Nothing fancy at all. In fact, it's got one lone property, and that's it, unfortunately. In a trapezoid, do you remember the family tree was in the middle? Why did we put them in the middle, separate from the kite and separate from the parallelograms? Because it only had one set of parallel sides, and you know what? That's all I got for the trapezoid. That's it, unfortunately. Or fortunate for some of you, because you don't have to remember anything about the trapezoid. It's got one pair of opposite sides parallel. That's it. Where we're going to have our attention today is on the souped-up version, the isosceles trapezoid. That's where we're going to turn our attention to today. What's so great about the old isosceles? Hey, well, it's still a trapezoid. So one pair of opposite sides are still parallel. That's true. What do you think happens when I add in this word from this year already? Isosceles. What do you think is going to happen? What's isosceles means to us? In a triangle, anyway. Correct. Two sides congruent, and those two sides will be the non-parallel sides. So we can put little hash marks here on A, B, and C, D. And can we stop calling them non-parallel sides right now? They actually have a name. The congruent sides in an isosceles trapezoid are called the legs. All right, those are the legs. And that is your first property down here. Legs are congruent. Legs are congruent. Next one. Remember when we were in a triangle? What did we say about the angles across from the congruent sides? What do we know about those angles that are across from the congruent sides? Anything else you think I should mark up here? Serena?
The top two angles?
All four or just separately congruent?
Separately.
Darn right. These are called base angles, everyone. Base. Don't get in that darn middle school mentality. Base equals bottom. No. Base angles. Those are the top and the bottom ones here. All right, so base angles congruent. Base angles congruent in an isosceles trapezoid. And I'm not going to write this down as a property because it's not actually an isosceles trapezoid property. It's the fact that these lines are parallel. What do you know about A and B and C and D? If these are parallel, those angles have to be supplementary. What type of angles do we call them inside the parallel lines? Oh, same side interior midterm coming. Whoa! Almost a month away. 27th. I know you're excited. So no, not the 27th. 25th. Look at that, huh? One more property, and I'm not going to draw it in because my diagram's just going to get sloppy. Not that it already is. Diagonals of a isosceles trapezoid. The diagonals are, you got a 50-50 shot. What do you think? You got a 50-50 shot here of saying the right term. And you failed. Congruent. Good try, Paul. You know? They are congruent. Unless there was a third option C, I don't know. What they would bisect each other, maybe?
No, I accidentally said parallel.
Oh, the diagonals are parallel, even though they clearly intersect each other. Thank you for keeping that to yourself. Yeah. Oh, any questions here? We're good? All right. I'll do the first one with you, and then I'm going to let you and your group get after it a little bit. All right, this first one here, we see I got a pair of sides, opposite sides parallel, and the other pair is congruent. It's an isosceles trapezoid. Do I need all three expressions up there? Do I need all three to put into my equation to find x? No, I threw x minus 1 up there to mess with your mind, and hopefully it worked. The only thing I need is x plus 5 equal to 3x minus 3. You don't have to use everything. You don't. Only in a proof. Only in a proof you should use everything. Right? 2x equals 8. Ooh, tough one here, huh? X equals 4. We just had to find the value of the variables. Yep. All right, good. All right, I'm going to let you guys go on number 2, but let's just talk about it briefly. I got my isosceles trapezoid. I have to find x and y here. I know I just gave you guys the property that base angles are congruent, but would that make sense here to set y equal to 6x plus 20? I probably don't want to work with that, right? And neither do you and your group. So there's got to be, I got these two angles that both have x's in them. I'll see you in about a minute and a half. Go right ahead, talk it over. How are you going to get x? And then how are you going to find x? How are you going to use x to get y? Here we go. Let's talk. All right. So on this one here, let's start with number 2 today. How are we going to set up an equation to solve for x? We just talked. Same side interior angles are supplementary. What'd you get for x, Matt? 16 in the house. There we go. Any issues, questions? All right, how do I use x now to get to y? 15. How do I get to y now?
You do 6 times 16 plus 20.
Because these are both,
Base angles.
good job, they're congruent. So 6 times 16 plus 20. So your value of y? 116 degrees, yes. All good, questions? All right, so this next one here, How do I find x there? Wow. And just so everyone knows, 34 is the entire base length, all right? 34 is the entire base length. Can I label anything else on my diagram? Do I know the lengths of any other sides? What's the other leg length? 13, right? The one leg's 13, the other leg's got to be 13. Hey, whoa, what type of triangle do I have over there on the left? What type of triangle do I have here?
Right triangle.
A right triangle? And I already know 2 of the sides? I'm almost starting to think Pythag. But I got a problem, though. I'm going to need to know that side before I can plug anything into Pythag. Right? I'm going to have to know that side length before I use it. Good luck. Good luck in your groups. Go ahead. Discuss it. Discuss it. Discuss it. The whole base is 34, remember. Whole base, 34. Okay. A lot of people are on the right track. It's just, am I really doing this right? Can I assume that this is equal to this? And let's talk some geometry here. All right, so when I draw this segment down that's perpendicular, which, by the way, can we have a name for this? Anybody know what I call that? You saw it in a triangle. It's the same name here. Altitude. Yeah, that's an altitude. I can make a trapezoid into a rectangle and 2 congruent right triangles. All right, 2 congruent. And some of you are saying, well, how do you know they're congruent? Do you just assume that? No. The base angles are equal, right? In an isosceles trapezoid, everyone agrees? The right angles are congruent, and so are the legs. You tell me, why are they congruent, the triangles? Angle, side, right? So that would mean by CP/CTC, those bad boys are equal, which gets you to your side length here. So if I make a rectangle out of this, that's 24, that's 24, right? Opposite sides equal. How much is left for the 2 sides here in the triangles? How much do I have left? 10, which we just proved are congruent. So each piece will be 5 and 5. Not out of the woods yet. I don't know if I heard some incorrect Pythag use here. Where's the 13 going? The hypotenuse, which is always across from the right angle. So that should have been plugged in for c squared. I don't know if we're in the mindset if we just see two numbers and they automatically mean A and B. No. The hypotenuse is your C. X and 5 can go either place. So what do we have? Plus 25 equals 169. Move the 25 over equals 144. And look at that. Nice perfect square for you. Nothing to break down. X equals 12. So just a reminder, in the trapezoid, you can break it up into a rectangle and two congruent triangles. I know, of course, I never, I know you're always hungry. You'd feel left out, unfulfilled, empty if we did not do it in geometry class approved. So there you go. Before you start, before you start, a couple things about it, just one thing about an isosceles trapezoid proof. In the proof, they need to give you either one, the parallel sides, or two, the congruent sides. Because you just can't assume by the looks. So does everybody see AD congruent to BC? They need to give that to you. AD and BC are congruent. That makes you automatically realize, what about DC and AB? Those are the parallel sides. You don't need to state that. That's part of this given right here. All right, but they do need to give you one or the other, so you know which one's congruent, which one's parallel. And I am done talking. Good luck to you and your group. How do I get those angles congruent? A lot of different ways. I'm just going to hear from one person to start us off. Oh, one, Meg. One correct, true fact in this problem. Oh, taking the easy one right away, huh? AB congruent to AB, a little reflexive, yep. And now look, don't change your proof. I know there's people in here that did not need AB congruent to itself. Don't change your proof. All right? There's another way around it without saying AB. 8, even though I know you did it a different way.
Do you want me to keep saying stuff as if we're doing it that way? Or
you know what? Just so you're good. I don't want to confuse people. Ready? Here you go. Couple ways. How many of you did the big dogs here? Anybody do those? Okay, no problem. So you guys did what? Side, 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 or side, angle, side? Or both? Side, 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 or side, angle, side, right? Make sure when you're writing that the angles are equal, that isosceles trapezoid implies, right? Make sure you write that. Implies diagonals congruent. Implies base angles congruent. And then CPCTC at the end. Some people did not use those two big ones. Take a look, just so you can be impressed. Some people use these ones here. Those were congruent by side, angle, side. CPCTC would be these angles equal, and then you subtract them from the base angles, which you said were equal. Not bad. Pretty good. Okay, so there's another way around it. And I think really that's probably the only way. There's no way you could prove these two right here congruent. There wasn't a way to prove those, so. Questions, all good? Please go to number 3, part C. I know most of you could probably realize it, but I didn't want any whining or complaining tomorrow. On part C, I left out the angle symbol there. Sorry. It should be angle BCD, measure of angle BCD. Everyone, look at this. We got 12 minutes to keep going with your group and practicing. Let's get rolling on the homework. Plenty of time.